All right, here we go. Lesson 3-4. Auxilary lines. Auxiliary lines. What does it mean to be auxiliary? Auxiliary means to help out. So these are lines which are going to help us in making proofs. Sometimes we need to draw them, sometimes they're drawn for us. So there's 3 types. All right. Actually, I think there's 4, but we'll only talk about 3. First of all, there's medians. First thing to note about median is that it's inside of a triangle. Yeah. So it goes from a vertex to the opposite side, specifically the midpoint. All right, so let's go over here. Let's take this triangle. Let's pick a vertex. I choose this vertex right there. Again, it doesn't matter which one you pick. You'll be able to do it for all 3 of them. And now we're going to go towards the opposite side, that direction, towards the midpoint. So I'm going to create the midpoint first of all over here. I'm going to show that it's the midpoint by putting 2 little hash marks. And now we'll draw the line that goes from there to there. All right? That there is the first median. We can draw 3 more medians. Let's do that just for the fun of it. So there's another vertex. There's another approximate midpoint. And let's grab green for our 3rd one. And let's come down here again. Our midpoint's about here. And we can split this side. So there we have. And notice they meet at a point. That isn't a coincidence. That will always happen. That point has a special name. We're not going to talk about that right now. It shall remain a secret. Mid-segments. These are also inside of a triangle. They go from midpoint to the other midpoint. Now, there's 3 sides to a triangle, so let's kind of show what this might be. So let's pick a midpoint. Oh, look at that. We have a midpoint here, P. P is halfway between B and A. Why does the phone interrupt me? We also have another midpoint, Q, over here. Yes? So I can draw a line. So PQ is a midpoint. Sorry, median. Again, there are other midpoints. So let's draw the midpoint on BC. Let's call it R. And then I can draw that. Yes. And finally, let's choose green for our 3rd. So RQ as is RP. These are all medians. A couple things to note about what's happened here in this process. They don't meet at a point like the last one. They do create little triangles, specifically 4 of them. And as you might guess, these 4 triangles are all equal to each other. They're all congruent. One last thing to note, and by the way, that means RP, for example, has 2 dashes, just like that side has 2 dashes and that side has 2 dashes, yes? And then if I were to go to the 1 dash ones, yes, then RQ is going to be congruent to those 2. Now, how do I know that RQ matches up to those 2? For several reasons, but I think the easiest one to tell is if I take, let's take yellow. Can we see yellow? Yeah. See, we got a line there. And this line here has to be parallel to it. My drawing doesn't leave something to be desired there, but those two lines will be parallel. Okay? And in fact, PQ will be parallel to BC. Yeah, and so because those two are parallel, I know that those sides are equivalent. So let's see, I think I need to go with 3 now. So this is 3 and this is 3. Does that make sense? So those triangles end up to be all the same. All right, they're a little mid-segment work. And now before, quick postulate here. I think when you write down, like, why can you draw the line, you're going to say, because I can draw auxiliary lines, because Mr. Larson said I could. And that's because we have a postulate that says you can always draw a line between any 2 points that you want. Okay? So 2 points determine a line. And we can pick whichever random 2 points we want in a triangle. Yeah? Say I want to draw an altitude, which is the next one we're going to draw. So I pick a vertex, and then I pick a spot, which makes it perpendicular. Yeah? I don't have to draw an altitude. We could draw other lines in a triangle, such as the median, the line that kind of splits the opposite side in half. All right? All right. Let's go to this thing, though, that you speak of, an altitude. What is an altitude? It's a little trickier than the other two, because it is not only in, it could also be outside of a triangle. Again, it starts at the vertex, and it goes to the opposite side, and is perpendicular. Make sure that you get that perpendicular thing in there. It's important. All right? So let's draw some altitudes in this one. All right, here we go. So there's my vertex. And now I'm going to draw a perpendicular line. That looks pretty good. And we'll mark that it's perpendicular so that if people are wondering, put a little box down there. And we can do that with the blue as well. So we'll pick this side, and again I'm going to go in a perpendicular fashion. Try to make it, see, that doesn't look perpendicular. That doesn't look perpendicular. That there looks pretty 90 degrees where they kind of meet up. And again, just so people know, it's perpendicular, see? Because we said so. And again, from this side here, I can go perpendicularly to the opposite side. And again, if people wonder, see, it's perpendicular. They too, by the way, will meet up at a point, always, regardless. Sometimes that point is inside the triangle, sometimes it's outside. So here's an example where the altitudes are outside. Here's a line, right? There's the opposite side. And here is my vertex that is kind of on the opposite side of that side. So now I'm going to draw my altitude. Again, if you draw it inside, that would be a kind of a bad idea because that is not forming a 90-degree angle for us there. Everybody see that? This angle here is not 90 degrees. Okay. So let's take and let's just delete that and draw a new one. So notice now I'm going to draw it on the outside, and that looks pretty good. Okay. And then we do, again, the same over here. There we go. And we'll do a black line for the last one. So again, we're going to have to extend this side. And we'll take the blue side and we'll draw a perpendicular. Yeah, and it looks like they don't meet, but that's because this red side just needs to be extended more. And you can see my drawing is a little bit off, but they're going to meet right here if I've drawn them accurately. as long as every side is perpendicular to the opposite base. Okay, so again, our triangle, just so we don't lose sight of it, is right here. All right. And now for a little proof. And then we'll close up. All right, we are given some altitudes. So I'm going to mark these two altitudes in my diagram. It's always important to do that when you get your drawing. So CD and BE are altitudes. And we know that AD and AE are congruent. We're trying to show, so I'm going to change the color, that this side is congruent to this side, that DE. All right, well, to do that, I think what we have to do is we're going to have to get some triangles congruent to each other. Now, there's lots of different triangles. You could, for example, try working with these triangles, but that wouldn't work. There isn't any way to get those two triangles congruent to each other without using something that we don't know yet. Okay? We could try to get, for example, this triangle congruent to this triangle. They're kind of overlapping triangles, and it's hard to see them. But it ends up those also would be very difficult to prove they're congruent. Could, but not with the tools that we have. Instead, there is a third pair of triangles that we are going to go for. There. And I'll mark the other one in green. There. All right, those two triangles will be congruent to each other. Now, how do I know that those are the ones? Well, remember those three-letter combinations: side, 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 postulate, side, and angle, side, angle. Right? If I look at that triangle, let's just highlight one of them. So I know that, for example, this side is congruent to the corresponding side on the other triangle. I also know that they share an angle. So I have an angle on the side, so that means I'm kind of working with one of these two. Now I either need another side or another angle. Unfortunately, this side here I don't know anything about. But I do know something about this angle here. It is a 90-degree angle. So I think we've got asa, as we say in the business. All right. Once we get those two sides together, then we can split that part off. So let's start off here. We got the given down. So angle A is congruent to angle A. Why? This is the reflexive theorem. So we've got my side angle. Now I need that other side, right? And this is angle ADC is congruent to angle AEB. Why are those two congruent? Well, because the wrapped right angle theorem, right? Technically, I should have said, oh, I have two right angles there, right? I skipped a step, if you see what I'm saying there. I'm not going to worry about that too much. We can see that those angles there are right angles. Therefore, those are congruent angles. Line 4, our two triangles are congruent now. Triangle AEB is congruent to ADC. Got to be careful how we name them, but order-wise. And again, this is reason asa. Okay, line 5. By CPCTC, we now know that AB is congruent to AC. Yeah. And finally, last but not least, line 6. We can now cut out that piece that is congruent, right? AD and AC. I can take and remove those two pieces, leaving me just the outside pieces here. All right? Which is what we were after, right? They wanted us to prove DB and EC are congruent. So, DB is congruent to EC and this is because of segment. Whether you call it addition or subtraction, I'm not going to worry about it. Segment, I think most kids like it when I say subtraction. Postulate, but notice addition, adding the opposite is the same. What did I put as 7 there? It should be a 6. All right, so in 6 steps. Hopefully that wasn't too painful for you and you followed the logic there. Again, these are auxiliary lines. There's 3 of them.